Let's do an example using our newfound knowledge. So we're going to find the center of mass of a tetrahedron with density given by x times z, and then vertices at these points, 0, 1, 0, 1, 1, 0, 0, 1, 1, and also 1 at the origin. Okay, so let's figure out what this region looks like. So let's sketch. There's the axes. Okay, and so I've got points at the origin, and see, so 0, 1, 0, so it's going to be 1 out on the y-axis, and then I've got one that's out here, so that's 1, 1, 0, and then I've got 0, 1, 1, so that's up here, and there's my tetrahedron. Okay. So now let's go ahead and set up this center of mass equation here. Okay, so the mass itself is just going to be the integral over this region of the density. So we're going to have this one, and we just need to figure out how to set up those bounds. So let's see. Well, the first thing to do, I think, is to figure out what that top plane is right here. So this one that's kind of coming at a slant. The other ones are going to be easy. Those are just parallel to coordinate axes and whatnot. So how do we find this? Well, the equation for that plane we can get by looking at the normal vector. And since this vector and this vector are both contained in that plane, the cross product of those two is going to give us the normal vector out here. So our normal vector will be, let's see, I, J, K across the top, and then 1, 1, 0, and then 0, 1, 1. And if you did it in the other order, that's fine. It doesn't matter. You'll still get the same tangent plane equation. And so this gives us 1 minus 1, 1. And so then that tells us that the, not tangent plane, what am I saying? Just the plane is x minus y plus z equals 0. You can tell it has to pass through the origin, right? So, so then let's see. So that tells us we've got our dz going from 0 up to y minus x. And we've got our density xz, so that's part of it set up. And then we need to figure out, okay, so after you've done that vertical integration from points up there to points down here in the plane, the resulting thing to look at is going to be this triangle that you have down here. And I can see that that's going to be from y equals x up to y equals 1, and then x is going to go from 0 to 1. And then I can integrate this sucker, and this is all pretty straightforward. I'll just do the first step here just to check out the substitution. So when we integrate dz, we get z squared over 2 evaluated across the endpoints, and we end up with x y minus x quantity squared from the z squared all over 2, dy dx, and that will be 1/2 the integral from 0 to 1 x 1 minus x cubed over 3 now dx, which is 1 over 120. Okay. Computing m,y,z, the x mean, this will be, it's going to have exactly the same setup, so I don't have to go repeat any of the pain for figuring out what the bounds of integration are. And now we're doing x, so I throw in an extra factor of x, so it's now x squared z, dz, dy, dx, and I do some computations, and I end up with 1 over 360. And for mxz, we can find the y moment, And again, I don't have to repeat the derivation of the bounds because it's still the same object that we're integrating over, but now it's x, y, z as our integrand, dz, dy, dx. And doing some crunching, we end up with 1 over 144. And then finally myz, mxy, our z moment, 0 to 1, x to 1, 0 to 1, y minus x. And now we've got x z squared, dz, dy, dx. And integrating some polynomials again gives us 1 over 360. So then let's see. So now we've got that our x mean is 120 over 360, which is 1/3, and our y mean is 120 over 144, which is 5/6, and our z mean is also going to be 1/3. So the center of mass is going to be at 1/3, 5/6, 1/3. See if we can draw that in the picture somewhere. So we've got, what was that? 1/3 and 1/3 and 5/6. So somewhere here-ish. And that looks about right. That looks like it's somewhere in near the center. As a reality check, it is inside the object. So this is a convex object, so we definitely expect the center of mass to be inside. Now, if your object's not convex, like say it's like a horseshoe or something like that, then you might expect that the center of mass is outside the object. But for something convex like this, that's not going to happen.